Okay class, we are going to be solving quadratic inequalities algebraically today. So for the first problem we are going to solve the inequality x squared plus 2x is less than or equal to 8. So what we're going to do is we're going to write the corresponding equation, which is x squared plus 2x equals 8. We're just going to replace the inequality with an equation, and we're going to set it equal to 0 in step 2. So we're going to subtract x to the other side. So you have x squared plus 2x minus 8 equals 0. So equivalently, we could solve the inequality x squared plus 2x is minus 8 is less than or equals 0. Those are equivalent inequalities. So essentially what we want to do is we want to know when this parabola is less than or equal to 0. So what we need to do is we need to solve for the x-intercepts. So solving for x-intercepts, so we're just going to factor it. If you can't factor something, remember you can complete the square, use the quadratic formula. Quadratic formula, completing the square, work 100% of the time, but factoring does not. Okay, so what we're going to do is we're going to factor this, and this one does factor. So go ahead and pause it and factor it. So it factors as x minus 2 and x plus 4 equals 0, because we needed two numbers that add to be 8 and multiply to be negative, add to be 2 and multiply to be negative 8. So now I'm going to solve, and I get x equals 2 and x equals negative 4. So these are what's called the critical numbers. So the critical numbers are the x-intercepts, and we're going to write them in increasing order. So it's negative 4 comma 2, and we're going to write the test intervals. And what the test intervals does is it splits up kind of your x-axis here. So I have negative 4 and I have 2. Not drawn to scale, obviously. So what we want to do is we want to test the parabola when it's less than or equal to 8, or equivalent when the parabola is less than or equal to 0. And if we graphed this parabola, its two x-intercepts are at minus 4 and 2. And we know, since the coefficient of the x squared term is positive, we know it's going to be an upward-facing parabola. So what we're going to do is we want to know when it's less than or equal to 0. Now graphically, I can see when this parabola is less than or equal to 0. I'm going to highlight it right here. It's less than or equal to 0. Well, it equals 0 here, and it's less than 0 here. Less than 0 meaning below the x-axis, or equal to at the x-axis. So that's how we solve it graphically, but algebraically, we're going to look at the interval. So my first interval is going to be from minus infinity out here all the way to 4. And then from minus 4 to 2, and equivalently from 2 out to infinity. So I'm taking my x-axis and I'm splitting it up into one interval here, the second interval here, and the third interval here. And my x-intercepts split it up into 3 separate intervals. So from minus infinity to minus 4 is going to be my first interval. And my second interval is minus 4. Oops, it should be a minus 4 to 2. And my third interval is from 2 to infinity. And I'll talk about whether it's a square bracket or a round bracket as well. So at infinity and negative infinity, it never actually reaches it, so they're always going to be round brackets. Since our inequality is less than or equal to, I know that it's or equal to, the equal to bit at minus 4 and at positive 2. So essentially, for quadratics, if the inequality is or equal to, it's going to be a square bracket, because that's equivalent to a filled-in circle. But if it was strictly less than or strictly greater than, then we'd be using round brackets at all of those spots. Okay, so sum things up. You set your inequality into an equation, set equal to 0, factor it or complete the square, find your critical numbers, and then whatever our critical numbers are, we're going to split our number line into that many intervals. So it's always going to be from minus infinity to the smallest, from the smallest to the next one. If we have a third one, it would be from here to the next number, and then from that number to infinity. It's always going to be in that pattern, which is why you want to write them in increasing order here. Okay, so we have our test intervals, and we're going to complete this table. So I'm going to fill out my intervals. So it goes from minus infinity to minus 4 to 2, and then from 2 to infinity. So what we're going to do is we're going to pick an x value in this interval. So just to draw the number line again, I have minus 4, I have 2. So I need to pick any number in this first interval. So I'm just going to pick minus 5. It doesn't matter just as long as it's here, and it cannot be an endpoint. So you can never pick the endpoints. Okay, so I'm going to pick it here, and I'm going to see, is that number above or below? Okay, so we're going to test the inequality. We're going to plug it into the original equality, or equivalently, with the one set equal to 0. They're equivalent, so it doesn't matter which one you plug it into. So if I plug it into the second one when it's less than or equal to 0, so I'm going to plug in minus 5. So I have minus 5 squared plus 2 times minus 5 minus 8. I want to know, is that number less than 0? Well, I have 25 minus 10 minus 8. This number is not less than 0, which tells me the parabola is up here. It's not less than 0. It's going to be above here. It's going to be a positive number. It's going to be up above. So then I'm going to pick a number between minus 4 and 2. Well, 0 is always an awesome number to pick if you ever can. Plug it in, and I have minus 8. Is that less than or equal to 0? And that's yes, which tells me that on this interval between minus 4 and 2, it is less than 0. It's going to be negative. Then I have the last interval from 2 to infinity. So pick a number over here from 2 to infinity. You can pick any. 5 is a nice number to pick. You could pick 3. It doesn't matter. I would avoid numbers like 2.91, but it would work. So plug it in. You get 5 squared plus 2 times 5 minus 8. I want to know, is that less than or equal to 0? So 25 plus 10 minus 8, that number is definitely bigger than 0, which tells me it's a positive number, so it's bigger than 0. So the parabola is going to be above the x-axis. So from there, we have one conclusion. So we know that the parabola, we got one yes. The parabola is less than 0, so below the x-axis on one interval between minus 4 and 2. So that you write the solution set, so it's minus 4, comma 2. And if you had two yeses, then we would write it with the union symbol and then the other interval. And we'll see that in the next example. Okay, so let's move on to example number 2. So for example number 2, same way, we're going to solve this one, and we want to set it, write the corresponding equation, x squared minus 5x equals negative 6, or bring all terms, x squared minus 5x plus 6 equals 0. So we are going to have to factor this. So remember, factor, complete the square quadratic formula. So go ahead and pause it so that you can factor it. And this factors into x minus 3, x minus 2 equals 0, or x equals 2 and 3. So these are the critical numbers. And graphically, if these are my axes, I have the value 2 and 3. Those are the two x-intercepts. So if I wanted to graph this, or equivalently, x squared minus 5x plus 6 is bigger than 0. If I was graphing this parabola and I wanted to see where it was bigger than 0, where it was above the x-axis, I know that this is an upward facing parabola also, so it's going to look like that. And where is it above the x-axis? Well, over here and over here. Well, what intervals? So the intervals over here and over here. And since I want to know where it's above the x-axis, right here it equals the x-axis. So we're going to be using round brackets on these. And we're going to solve this algebraically. So we're going to write our test interval. So it's always minus infinity to the smallest, and then from the next one to infinity. And we're using round brackets this time because we want to know where it's above. So it's equivalent to being above, not equal to the x-axis. So again, if it's just less than or greater than, it's going to be the round brackets. So those are our test intervals. So what we're going to have to do is put it in, I skipped on. The test intervals are from minus infinity to 2, and then from 2 to 3, and then from 3 to infinity. It's always from the smallest, from minus infinity to the smallest, from the smallest to the biggest, or the next one, and then from the biggest all the way out to infinity. So we're going to fill out the table. So the intervals are from minus infinity to 2, from 2 to 3, and then from 3 to infinity. So I have 2 and 3. So I need an interval between minus infinity and 2. So some number out here, like 0. And I want to know, is x squared minus 5x plus 6 greater than 0, or the original? You get the same conclusion either way. So if you have 0 minus 0 plus 6, is that bigger than 0? When I plug it in here, yes, it tells me that it's above the x-axis here. Okay, and graphically we know that that's true. So between 2 and 3 is 2.5 would be a number between 2.3, but since I'm going to have to square it, I can't square 2.5, but in fraction form, 5 over 2 will work. So I'm going to do 5 over 2 squared minus 5 times 5 over 2 plus 6, and is that number greater than 0? So you're going to have to deal with fractions. So you have 25 over 4 minus 25 over 2 plus 6. Is that number bigger than 0? So find a common denominator. So if you write it all over 4, the middle number is 50 over 4 and 24 over 4. And so we end up with minus 1/4. Is that bigger than 0? No. We need a number between 3 and infinity. So you can pick any number. 4 is a number. Remember, you can't pick the actual critical numbers. So 4 squared minus 5 times 4 plus 6, is that number bigger than 0? 16 minus 20 plus 6, 16 minus 20 plus 6, that number is definitely bigger than 0. So what it tells me is when you have a yes, no, yes, yes, it's above the x-axis here, no, it's not above, so it's below the x-axis, and then yes, it is above the x-axis, because we wanted to know what if it's bigger than 0, the x-axis. So now we have two yeses, so we know that this parabola is above the x-axis, bigger than 0, or equivalently, this parabola is above y equals -6 line on two intervals from minus infinity to 2 union 3 to infinity, because we had two yeses. Okay, so sometimes you can have all no's or all yeses, because if you think about it graphically, sometimes your parabola might be up here. And if we wanted to know when this parabola was greater than 0, well, it's always above the x-axis, so this would be all real numbers. And if you had the parabola down here, if you wanted to know when this parabola was bigger than 0, well, never. It's always below the x-axis, so that would be never. So sometimes you could have two of them, sometimes you could have the middle one, sometimes you could have all three of them, and sometimes you could have all of them being no's. You should never get two yeses and then a no in order, or two no's then the yeses. If you did, then you set up your intervals wrong, which means you probably factored it incorrectly. Okay, so again, you can have all yeses, all no's, a no in the middle with yeses on the outside, or the opposite, two no's with a yes, or two yeses and a no. Those are your options. So that is how we are going to solve quadratic inequalities. So I hope you have a wonderfully delightful evening, and I will see you in class.